So far in this chapter, on every problem we've worked, we've assumed that interest is compounded annually, and if there are payments, that they occur annually. In reality, a lot of times interest is compounded more often than that, and payments may occur more often than that, perhaps monthly, for example. So it's important for us to know how to deal with those situations. It's an absolute must. So if we have a lump sum today and we want to find the future value, it turns out that the more often interest is compounded, the higher the future value will be. Now let me show you a specific example of what we're talking about. The very first problem we worked in this chapter was this one. We took $100 and we grew it for 3 consecutive years at a 10% rate of interest. Okay, and we found out that the way we find that future value is by taking $100 times 1.10 to the third for $133.10. That type of problem should be second nature to you by now. That should be very easy. But let's throw a little twist into things. What happens if the interest is compounded semi-annually instead of annually? Well, we have to make a couple of adjustments. It's not that hard, we just have to remember to do it and be consistent. The one thing you've got to remember when you're solving any kind of time value of money problem is to keep it straight in your mind what the periods are. Are they years? Well, if so, then you need to count the number of years, and you also need to be using an annual interest rate. Well, what if it's half years? What if it's semi-annual compounding? Well, in that case, we need to be using a semi-annual interest rate, and we also need to be counting the number of half years instead of counting the number of full years. So in this case, what do we have? Well, if the annual interest rate is 10%, then the semi-annual rate would be half that, or 5%. And we would no longer have 3 periods, we'd have 6, because if you look at a 3-year time frame and you count the number of half years in that time frame, obviously that's twice as many, or 6. So in this case, the interest rate per period is 5% and the number of periods is 6 instead of 3. So we'd take the present value of 100 and instead of multiplying by 1.10 to the third, we'd multiply by 1.05 to the sixth, and we would end up with 134.01. The reason this answer is slightly higher than the previous answer is because here you actually start earning compound interest a little sooner. Now I know it's 5% in this period and 5% in that period. It seems like it ought to be the same as 10% over the first year, but you've got to understand that in this second period you're actually earning interest on the interest that was earned in the first period. So the compounding process gets started sooner, and so you end up with a little bit more at the end. Okay, whenever we talk about non-annual compounding, we have to be careful about exactly which interest rate we're referring to. It gets a little confusing sometimes. First of all, there is the nominal rate, and in some cases this is called the APR, or the annual percentage rate. Although if you're talking in mortgage lingo, the APR also includes the effects of other things too. So the nominal rate is simply the quoted or stated rate on a loan or on an investment. So the nominal rate actually doesn't tell the whole story. You actually have to also state the frequency of compounding. So let's say we had a rate of 8% nominally. Well, that's great. How often is it compounded? Is it quarterly? Is it daily? Is it annually? That has to be known for you to really understand how much growth in your money that you'll be getting. Okay, then we have the periodic interest rate. The periodic interest rate is really what we use in our calculations. And we find it by taking the nominal rate and dividing by m, where m is the number of compounding periods in a year. Like in the previous example, m was 2, because semi-annual compounding means 2 compounding periods per year. If we did quarterly compounding, m would be 4. If we did monthly, it would be 12. If we did daily, it would be 365. Hopefully you get the idea. Okay? Just divide the annual nominal rate by however many compounding periods there are in a year, and that gets you the periodic rate. There's also something called the effective annual rate, which is abbreviated EAR sometimes. Sometimes you'll also see EFF percentage. Think of that as the effective percentage you're earning. Sometimes you'll see APY for annual percentage yield. It's all the same thing. And that's the annual growth in your money that you're actually earning, accounting for the compounding that's occurring within the year. So there's a formula, though, for the effective annual rate. And it's like this: 1 plus the nominal rate divided by m. And by the way, this nominal rate divided by m, this part right here, is the same thing as the periodic rate. Okay, so you could say 1 plus the periodic rate if you wanted to, or you could just leave it like that. Raise that to the power of m, and then subtract 1. So in that last example we did, we had to take the nominal rate of 10% and divide by 2 because it was semi-annual compounding. I guess that would give us 5% right here, or 1.05. And so you could take 1.05 to the power of what? 2, and then subtract 1, and you would get 0.1025, which is 10.25%. Okay. What that tells you is that you would be just as well off receiving 10.25% interest annually as opposed to 10% interest compounded semi-annually. Either way, you would end up with exactly the same growth rate in your money. Okay, the more often interest is compounded, the higher the effective annual rate will be. Let's just assume again that we've got a 10% nominal rate. Well, if it's annual compounding, the effective rate is just the 10%. And we just saw on the previous page that with semi-annual compounding, it would be 10.25%. Quarterly compounding would give us 10.38%. Monthly compounding would give us 10.47%. Daily compounding would give us 10.52%. So you can see that there is an increase in the effective annual rate as you go to more and more frequent compounding. And also, the higher the nominal rate, the more a difference the compounding frequency actually makes. Here it doesn't look like a tremendous difference, and it's true, it's not a tremendous difference in the effective annual rates, depending on the compounding frequency. But if we went up to 20 or 30% nominal rates, kind of like credit card companies charge, then it would make a bigger difference. So, recapping all of this, when do we use each rate? What is it exactly? Well, the nominal rate is simply stated in the contract. We don't actually use it much in calculations. We don't really write it on our timelines necessarily. It's just the stated interest rate. We don't really know anything until we know the compounding frequency as well. The periodic rate, that's what we use. Okay? We have to take that nominal rate and divide by however many periods there are in a year, and that gets us the periodic rate. And that's what we put into our financial calculator, or we put into an equation, we write it on a timeline. That's what we use to work the problems. The effective annual rate is typically used to compare two investments. Let's say that you've got one investment that'll pay you 8% compounded annually, and you've got another investment that only pays 7 3/4%, but it's compounded quarterly. Which one is better? I don't really know until I find the effective annual rate. Okay, so We had been looking at this problem of the future value of $100 after 3 years with a 10% interest rate. And we saw for semi-annual compounding, again, what did we have to do? We took the 10% and cut it in half, and then we had to multiply the exponent by 2. Here's how we have to adjust the future value formula. You'll notice that if you take out m from this formula, or if you just let m equal 1, then this is just the good old future value formula. There really is no difference. Well, this is just showing you what adjustment you've got to make. It's just showing you that you've got to take the annual rate and divide by the number of periods in a year, and you've also got to take the number of years and multiply by the number of periods in a year. So down here, that meant that we had to cut 10% in half, making it 5% for a semi-annual rate, and we also had to take 3, the number of years, multiply it by 2, and get 6 half years. Well, what if we had done quarterly compounding? It wouldn't have been much different. We would have just had to take 10%, divide by 4, and that would have given us 2.5%. So here we'd have 1.025. And then we'd have to take the 3 years and multiply that by 4, and the exponent would be 12. There are 12 quarters in 3 years. And we would have ended up with a slightly higher answer, not surprisingly. Here's a question for you. Can the effective annual rate ever be the same thing as the nominal rate? The answer is yes, but only if you have annual compounding. If you have annual compounding, like we assumed for about the first half of the chapter, then all of these distinctions don't even matter, because the nominal rate is the same thing as the periodic rate, and that's the same thing as the effective annual rate. There are no differences between the 3 types of rates. But anytime you have more often than annual compounding, so semi-annual, quarterly, monthly, daily, anything more often than annual, the effective annual rate will always be greater than the nominal interest rate.